Welcome, everybody. My name is Andrew Bennett. I'm an advisor with the Kootenai and Boundary Farm Advisors, and it's my pleasure to introduce Bruce Naka to everybody tonight to impart his wisdom. The series that we're starting here is a 4-part webinar, Irrigate Better. And our focus is on BC's Kootenays and boundary regions, but if you're joining us from further afield, welcome. This should be pretty applicable across BC. Another name for this might be save time, save money, and grow more. This is really about ways that we can make farming more efficient, and water is crucial. I'm not going to go through any of those details. You're here because you know that already. I would like to thank all of our funding partners that have made this possible, and a special thanks to Andrew Peterson of the Ministry of Agriculture and Ted Vander Gulik, who is BC's premier irrigation guru, a water engineer. Bruce and I last summer took a couple of weeks to tour all over the Kootenays and visited all kinds of people doing amazing things. Really, we saw all kinds of systems from everything you can imagine and every kind of farm out there, and had a great time. But despite all the diversity, really what came through is that some of the problems were some of the issues that people were facing were really consistent. They were quite regularly recurring. And that's what Bruce is going to look at today. Some of the real core fundamentals that really apply to every farm and that are often missed. Some of these key points that can make a big difference. So what we've done is condense some of these lessons into 4 main parts, but we have some room to do some other topics as well. So as we're going along, if there's an idea that you have that you would like Bruce to cover in the coming weeks, please do let us know. There's going to be plenty of time, we hope, at the end here for questions and answers. So please put those in the chat as we go along. I want to take a moment, though, to just recommend a few resources that are available in BC for free, for the most part. For example, the BC Irrigation Sprinkler Irrigation Manual. I highly recommend that to anybody who's trying to DIY their system. It's got a lot of these core fundamentals wrapped up in it. But there's assessment guides, the Trickle Irrigation Manual you have to buy from the Irrigation Association of BC. There's also BC Agriculture Water Calculator, and more recently, the Irrigation Water Use Calculator. I'll be doing some videos that I'll be posting on YouTube in the coming months that show how to use those calculators. They're very, very helpful when we're assessing our water needs. On the side here, I've listed some of those key issues that we'll be covering. Leaks, leaching, and uniformity. I mean, that's really what it comes down to a lot of the time. Stop those leaks and get the schedule right, and get the emission to be uniform. So we'll be going through all of that in the coming weeks. These are some other useful guides. You have to buy some of them. Some are free online. What I would highly recommend, though, is also taking a look through some of the facts the government has available and that the Climate and Agricultural Initiative has also put out that cover really the gamut, from drought management to calculating evapotranspiration to you name it, across the board. So last thing I'm going to say before I pass it on to Bruce is that a lot of this can be overwhelming. And one thing we really do recommend is it's worth the services of a professional. So there are certified irrigation professionals such as Bruce, such as myself, that go through programs at the Irrigation Industry Association of BC to certify that they can make designs that will work for your farm. You can access these plans sometimes through the Environmental Farm Plan program, which I also recommend. When you have an environmental farm plan, you can apply to get an irrigation plan for your existing irrigation system, and you can get money towards projects that will improve your system and improve your water efficiency. And finally, again, I'm an advisor with the Kootenai and Boundary Farm Advisors. We are a free service to any farm in the Kootenai and Boundary regions. We do one-on-one advising, farm visits. We give our farms access to experts. We put on workshops. and really just do whatever we can to meet the needs of our farms so that they can be more successful and produce more. That's plenty for me. Over to Bruce. That's why everyone's here. So again, just use the chat, and Bruce, it's time for you to take over for me. So thank goodness. I hope this came through. My internet's dying, so I'm gonna get out of here before it's too late. All you, Bruce.
Good evening, everyone. Thank you for joining me today. So the topic that we're talking about is the anatomy of an irrigation system. It's a good starting point, and I think that the only way, if we can cover the whole gambit of an irrigation system, right from the source of where you're getting your water, all through the preliminary necessary material in order to pressurize your water and deliver it to your farm, how you would filter your water, how you would control it if you had too much pressure. All of these devices are all in the anatomy of an irrigation system, which is going to maximize your efficiency of it. Okay, so the first thing that is necessary in going into start up your irrigation system, probably most of you folks out there have already done this, or it was established when you purchased your property, or it's been forever, but you can get your water in one of 3 or 4 different ways. Purveyed water, which is the easiest, where it's supplied by municipality, irrigation district, etc. You're paying for that through charge fees from the purveyor. In that situation, they are I'm living in the Okanagan, and we have had issues back to 2003 where we had some drought years where there was a water shortage, and so it was necessary for you to astutely use your water, and there were a lot of meters and things like that, which I know a lot of people frown at, but I'm going to talk to you a little bit about the fact that a meter actually can be a valuable tool for you as well. So in purveyed water, one of the things that we're looking at is if it hasn't happened anywhere yet, but down the road, what you're going to see is purveyed water where if you are in excess of what they expect you should be using for in a given year, you may be paying more for your water. It's happening in the States, and it could be happening here, so it's something we have to watch. But purveyed water is nice. It's easy. You don't have to worry about any other devices such as pumps or gravity feed systems or anything like that. There's your water at your tap, and away you go. Surface water licenses, where you're getting water from lakes, rivers, streams, or springs. You have to purchase a license for that, and you pay annual fees for that. Groundwater license, this is new in 2016, and as probably many of you already know, with the Water Sustainability Act, that license was required since 2016, and we're going through that process, and they're slowly pecking away at it and trying to get everything in place. We're not going to talk too much about licensing today. There will probably be other seminars coming up in our series, and we can specifically look at licensing in the future ones. Unlicensed other opportunities, and I'm going to go into these a little bit, are snow melt and rain on property, or any water catchment that you can possibly get. This is a valuable tool, and you could actually use this to augment what you have. So in years where you do have shortages, if there's any opportunities whereby you could collect some snow, collect some rain, you may, by digging out a dugout or a pond, we've had some pretty sophisticated reservoirs go in areas. So this is all very important. I think the one thing that I do want to point out here is the fact that in systems where you have an excellent water source and you've been able to develop that water source, it's going to make a lot of difference in the value of your property. So that's something we should always keep in mind. Okay, here's a picture here that's I like, and it kind of gives you an overview of your irrigation system. So your irrigation system, you're going to start from your water source. Your water source is going to be from a purveyed source. It's going to be from a well. It's going to be a gravity feed system, etc. So in this case here, we have a highlight around our well pump. Your well pump that's delivering your water to your system. If it was a gravity feed, that would be at that point, or if it was a purveyed point, it would start with your connection to the municipal water supply. From that, a lot of the apparatus that's shown here, valves, pressure gauges, backflow preventers, many of these devices are on any type of system that you have. So these are all common, and they're all important in being able to control your water. This is the point of your system, which is actually giving you the ability to control your pressure, control your flow, gauge it at that point, reduce your pressure if it's too high. This is your control center right here. Here highlighted, I mentioned some of these things. These are other devices that are on this main connection point, and we'll have a more detailed schematic of this a little later on, but you'll have items such as vents. Air vents are very necessary. I'll go into detail why you should have air vents, and all of the nemesis that can be created by not having air vents in your system. Filtration, depending on your quality of your water, is very important. Meters and gauges, of course. Then you have your emission devices. Irregardless of your type of system, you're always going to have a main line. The main line is going out to your system in any type of a system. If you have a drip irrigation on a vineyard or on an orchard, or if you have a hay field, you still need a main line with hydrants and that to connect onto. The appropriate sizing of that main line and the location of it, we will go over in a little bit of detail. We're not going to go into a lot of design here, but we will be looking at all of the necessary equipment that is off of a main line in order to facilitate irrigating your crops. Water sources. In this case here, we're looking at what do you need in a water source if you are drawing water from a stream. You have a gravity intake system on if in this case on a stream. It's very important that the way you are drawing your water into the system, you have to think of a few different things. You have to think of a way where you can bypass trash from entering into your main intake of your system. If you're going to screen it, it's important, I feel, to screen it in 2 steps. The first step would come with a coarse screen, and the second step would come with a finer screen, so that you're not going to plug up the fine screen right away. So there's methods, and if you look in the BC Sprinkler Manual, Andrew was mentioning that prior, that gives you some excellent photos and the methodology that you would go through in setting that up. Screens are very important if you're tying into your water sources from a lake or a pond or a creek. Department of Fisheries regulations require you to have a mesh size of less than 0.1 of an inch, and the speed or the velocity of the water going through that screen should not exceed 0.1 of a feet per second. So for an example, if you required 1,000 gallons per minute, you require a 60% opening on an 8 mesh screen, and you would need a minimum of 14 square feet. I think in the actual calculation of that, it would be actually closer to 25 or something like that would be a recommended 25 square feet, 26 square feet, that type of application. Now, ponds are something that if you're drawing from a pond, obviously a stagnant water in a pond can create algae in there. In order to eliminate that or minimize that, there's many aeration devices that are out there. I think that a good example of utilization of ponds are golf courses. Golf courses use a lot of ponds. You'll see a lot of fountains on them, and that's for aeration purposes, just moving the water around. I think it's really important that you address that. And as Andrew said, in some of our travels, when we went through the cookies, we did see some ponds and we did see some issues where perhaps with a little bit of aeration, movement of water, even as simple as taking off the discharge on your pump and running a pipe into your pond and aerating it that way, it would be helpful. Would it be the end all? No, it wouldn't be, but it would be very helpful. Movement of that water in that pond is going to minimize the amount of algae buildup in there. Something that a lot of people don't really recognize, and I hear this a lot where we're actually looking at rainwater harvesting and that for systems, is that how much water you really do need in order to irrigate. The example we have here is to irrigate 1 acre, you require 2,000 cubic meters of water. 2,000 cubic meters of water is equates out to 528,340 US gallons of water. So that's a ton of water. In order to have the supply of water that much, I mean, if you don't have a continuous supply feeding into it, you would require 1/4 of an acre of area 7 feet deep in order to have enough water to irrigate that for the course of the year. So it's not an easy step. It can be done though. I think that one project that I worked on not too long ago, we had a storage facility for 17 million gallons of water in a 3 acre, 2.5 acre lake that was developed. We could only draw water during freshet. And from that, that was the water. So basically, you could be drawing the water up to the maximum that this farmer was allowed, and he had to store it. So he was storing 17 million gallons in a lake that was 65 feet deep at its deepest, averaged about 25 feet deep overall. And he had to fill it up until probably August, and his irrigation was required until September. So it can be done, but it's you know, it's a lot of work, but can be worthwhile. Drilled wells into aquifers, which are underground water in cracks. The flow that's available and is determined by the size and connectivity of the cracks. Now, if you do get a pump installed into a drilled well, it has to be done by a qualified pump installer. That is something that was mandated, it must have been close to 10 years ago, if not more. I'm guessing at that right now, but just keep that in mind if you're considering putting in a new pump. So essentially, I'm sure many of you know about this, but a well is comprised of, at the bottom of it, there's usually a screen. If it's a drilled well, there would be a casing that's put down in there. You're going to get your water at a certain level within there, and it would have to be sealed. And a well that is drilled should have an ID plate of it on the top of it and the cap at the top of it as well. I think it's important. And one thing that I did notice in a lot of my travels is the fact that a lot of times, maybe if you've purchased a piece of property or something like that, it's very important that you should be presented with a well log from your well. In other words, when a well is drilled, typically the well is tested before they've gone to the next step of actually putting in a pump into the well. So your water log will tell you what depth of water they would recommend you to put that water at, what your flow capacity at that point is, and that's valuable information. Before you go ahead and start doing developments in your property, and honestly, I've seen this happen a lot, you should be good and sure of that water, or you should have a backup plan, because if that well isn't able to produce what you need, you're going to be in trouble. So even take a look, and it will vary from area to area, but you know, do a little bit of research. Look at some of the neighbors around there and see what average depths they've got to. Now things change, but it's going to give you an idea when you're drilling a well. Water distribution, pumps, pipes, and components that you require for the different systems. Well, we're going to look at some pump systems. Again, this is an anatomy of a system, so we're not going into a lot of detail. As you can see, I'm just kind of overviewing this, and I hope that the value that you'll see from this is the whole gamut of everything we're going to look at. But we will go into more detail. We'll be talking more about pumps in future sessions. We'll be talking about filtration, many other things. So let's start with pumps. Pumps that you'll see mostly in irrigation would start with a centrifugal pump. The centrifugal pump is usually a pump that will suck water in from a suction line, which will go into your water source. It draws in water from usually with a screen over the end of your pipe. A check valve is necessary so that water isn't running out of it. A lot of times, a big centrifugal pump has to be primed. And the one thing about a centrifugal pump, its limitations are the fact that in our areas here, as a rule of thumb, you cannot draw water up more than 15 feet of suction. So the height of your suction line cannot exceed 15 feet, otherwise you will lose your suction. A lot of times in systems I see suction lines going in. They should be, if you're going to use a rubber or a plastic, it's good to use a wire reinforced suction hose so it doesn't collapse when you'll lose a vacuum. Suction lines should be larger than your discharge line to produce the amount of water going into it. And suction lines should not have sharp right angle turns in it. It creates cavitation. The downside of a centrifugal pump is the fact that a suction line, it is very difficult for a pump. It's more difficult for a pump to suck than it is to push water. So the next step up from that would be a submersible pump, which you see in the middle. Submersible pump, you're pumping your motor or down in your well. They usually have a whole stack of impellers on the inside of them, and they will be pushing the water up. Submersible pumps, and then the next step up from a submersible pump is a line shaft turbine pump. The line shaft turbine pump, your pump is down in the well, your motor is at the top, so it's easier to service. There is other types of jet pump. Jet pumps are primarily used in domestic types of applications, not used in large volume situations. Over on the side, we also are looking at right now, the more sophisticated irrigation systems come with variable speed drives. A variable speed drive on a pump will drop down. As your requirement goes down, it will drop down in its power requirements, so you won't be utilizing as much power. It works in stages. The pipings that you're going to be using on your irrigation system, you know about most of them. PVC pipe is commonly used right now. It's life expectancy is 20 to 40 years. I think it's brittle. If it's on top of the ground, any top of the ground, I highly recommend maybe not using PVC because it will degrade you with UV. PVC pipe has improved a lot in the last 20 years from what it was, but it still can be brittle, especially in the colder times of the year. Polyethylene pipe is used a lot in Alberta and other areas. It's more flexible. It doesn't have as high a pressure rating. Your fittings go on the inside of it, and it can cause problems as well in your flows capacity because of that. Right, to finish that. A lot of the newer systems now are going to HDPE type of piping, high density polyethylene. That will last for hundreds of years. It's still costly, and the fittings are expensive, and you need the specific fusion equipment. But we are seeing a lot of newer systems, larger systems going in with high density polyethylene main lines, and like the slide shows, you can get 100 plus years out of HDPE poly. Aluminum piping, I don't have to say a lot about it, other than the fact that we will be talking about some of the challenges with leaking on aluminum piping. But it has been around, and it is, for a portable line or something like that, it's very functionable. Sizing lines. When you're sizing your pipe, we're not going to go into a lot of detail about this right now, but there are a couple key things that you have to think about in that. When you are sizing out a pipeline, it's key to know the inside diameter of that pipe. You want to know the wall thickness of that material, and you want to know the pressure rating of your pipe. So in other words, if you were hooked up to a purveyed water system, and they are supplying you water at the rate of 150 pounds per square inch of pressure. You certainly don't want to use 160 to 100 pound pressure pipe, because you're right up at the limit, and it's not going to allow for any hammering, which is an issue that you have in any piping. Water hammering or surging occurs when water changes direction quickly and it hammers back, and it can come back at 2.44 times the pressure that it was going in one direction when it hammers back. So water hammer is a big nemesis in water systems. The other thing that it has to be considered when you're selecting a pipe is the coefficient of roughness of a pipe. A steel pipe, for example, especially a rusted one, is going to have a lot more challenging of a water course than, say, a smoother PVC or HDPE pipe on the inside of it. So when we're calculating on friction losses, the coefficient of roughness is important to know. You have a multitude of different types of valves. What I want to talk to you right now about is a ball valve, a gate valve, or a globe valve. Excuse me 1 second. Ball valves and gate valves are utilized. One thing at a time I think they are used incorrectly is if you have a deep valve into the ground. I will see a lot of gate valves where people have made up keys to open and close a gate valve. If that gate valve is down 3 feet in the ground, after a while, they're usually just a pot metal on the handle, and they're going to break on you. If you have a deep valve, you're better off to go with a curb box type of a valve. It's got to have a rod on it, and it's designed for deep burials. That would be the type of valve you want to use on it. The one other thing I want to quickly mention about valves is a gate valve should be open or closed. As you can see in the picture there, a gate valve is actually a gate that sits into a seat. If you use it to throttle and not open it up as much, so if you want to control your flow going through it, you're going to wear your gate prematurely. Gate valve should not be throttled. A ball valve can be throttled very, very easily just by turning your ball around. The Achilles heel of a ball valve is in the wintertime, they should be left half open. Otherwise, if you get any buildup on the inside of it, the water inside of the ball, it'll usually crack the housing of the valve. A globe valve is the best valve that you could use if you want to use it for throttling on. You don't want it to be all the way open. Utilize a globe valve. A globe valve, the water has to come up, over, and down, and it's designed for the purpose of throttling. Electric valves, I'm not going to talk to you too much about it today, other than the fact that sizing of an electric valve should be considered. If you oversize an electric valve, it can cause you some issues on shutting and that. Pressure regulation valves, these are very important to have in the system. If your pressure is too high, a lot of people will put in a pressure reducing valve. A pressure reducing valve, typically like one that you would be using in your house, is just a spring reaction on a valve. The downside of a pressure reducing valve like that is it doesn't have a pilot. Like you can see this one here, this is a Nelson, and it has 2 pilots on it. One is a pressure reducing, one is a pressure sustaining module on it. What that means is pressure reducing is straightforward. It reduces your pressure. And sustaining it will maintain a certain pressure in your inlet side. If you require pressure to backflush a filter or something like that, you need to sustain your pressure. That's where that would come in handy. With all these tubes and a pilot, a pressure reducing valve in this fashion will modulate to your flow. So if you're running a low flow or your maximum flow, it's still going to maintain that pressure. In circumstances where you have water hammering, one of the best methods in order to minimize the effects of that is a pressure relief valve. Again, it has a pilot on it. And this is a quick reacting relief valve, which anytime you can preset it to whatever pressure you require, and it will adjust accordingly. On a lot of drip irrigation systems and likes of that, you'll see all sorts of these type of regulators. The one thing I caution on that is to make sure you see the flow range on them. They will all say the flow, like this one here. They'll say 10 to 35, or 5 to 12 gallons per minute. Do not exceed that. Anytime you do that, you're going to be restricted on your flow. Water meters. Water meters are used in irrigation districts, a turbine type of meter. These are municipal meters with electronic reads on them. Water meter is primarily there for your total quantitative flow in your system, whereby a flow sensor or a flow meter is giving you your flow by. That's going to tell you how many gallons per minute, how many cubic meters you're using at a given time. And I was talking to you a little while ago about flow meters and flow sensors. This is where a flow meter and something like that, if you see a large amount of water that has gone through this meter, it's giving in, you know, if let's say you were hooked up and you have an electric system downstream and you know how the size of your zones, if this meter is showing an excessive read, it's telling you have a leak or something in your system. So it can be a tool for you. Check valves, one-way valves, there are all types of them. I was talking about a check valve utilized on a suction line on a pump, but a check valve is going to eliminate water from going back. So anytime you want to maintain the water in your piping system, check valve is necessary. Backflow prevention devices are primarily required on pervade water systems. Although there is talk right now that on groundwater and even on some other circumstances where there is a shared water source, that backflow preventers may be required on other applications, other pervade water. I'm not going to talk to you about this little anti-siphon device too much. That's something that's on a domestic supply. A pressure vacuum breaker has to be at the highest point on your system. Economically, a double check valve is very similar in price to a pressure vacuum breaker. So I would avoid the pressure vacuum breaker and go with a double check valve. A reduced pressure principle double check valve. This is what you'd use if you were fertigating or chemigating into your irrigation system. So the degree of possibility of a backflow situation requires you change your backflow device. Reduced pressure double check valve has two independent checks, and if both of them fail, the system will automatically vent to atmosphere through here. Whereas a double check valve has two checks, but if they both fails, then you can get a back siphonage situation. Filtration is necessary. I see a lot of filters that go in, and the one issue with the filter is you need to size the filter based on the quality of the water, as well as what you are utilizing, what's your downstream emission devices. Drip irrigation system or something like that with smaller orifices, obviously you want to go to something that's going to do a good job on something like that. Sand filters do an excellent job for that circumstance. You can get this here is a filter which has an orifice plate across the top of it. You create velocity going through these orifices, and it continuously washes off a screen, and you can have a ball valve at the bottom of it, or you can have and a little battery operated controller to maintain that. There are manual disc type of filters, which are nicer than a screen because you just got to separate it and rinse them off. Or you can go do one like this, which is a self-cleaning filter. They do very well. It's got a gyro that moves around on the inside of it, and it continuously is washing the screen off. It has a pressure differential switch. So when your pressure drops more than 5 pounds over what it normally does, it automatically backflushes itself. So filtration is a very, can be a very sophisticated system, but you can do very well with a disc type of a filter. The key, I say, is based on the quality of your water. You can not oversize a disc system or a filter into a system. In other words, if you have a 2-inch water supply and you're utilizing 50 gallons per minute of water, don't automatically put in a 2-inch filter. You may want to look at the surface area of your filter, and it'll show in any of the specifications of the filter. You may want to go to a higher surface area so you're not cleaning it as often. Air release valves are a very overlooked device on the operation of a system. Air relief valves should be installed in irrigation systems at all the high points on your main line. In addition to, if you have a very extensive long main line, and generally rule of thumb, every 1,000 feet or every change in direction up or down, you should have an air vent to evacuate air out of the line. The aluminum air vents that you see over here, which have typically been used in the past, are good, but they're just releasing air out of a system. The ones like the ones up here, these are a kinetic type of an air relief valve. So when you're emptying a line, it's allowing air to come into the line to empty it quicker. And when you're filling a line, it's going to evacuate the air out of the line on your system. Air trapped in a system is one of the nemesis that's creating all of the problems that we had discussed in water hammering and surging. So you want to relieve the air out of your line. I can't emphasize enough the importance of it. Here's an example. This is a vacuum, but this is what can happen to a pipe in a vacuum situation where you're not relieving the air out of a line. It'll collapse, and that's a large pipe. So high points every 1,000 feet. When you have a filter, if you have a manual clean filter, you're opening up, you're allowing air into your system. It's important you put an air relief valve on at that point as well. Points of connection. I'm not going to go into a whole lot of detail on this right now, but I think there's some key ingredients on here. And this particular one, we're looking at a backflow preventer. I know this particular instance, he is drawing from a pond, but there is a cross connection onto a water supply. So he has a backflow preventer on here. Here's the filter that he's using. It's a disc type of the filter. He has an isolation valve up here as well. In Canada, in the northern outlets, we obviously need blowouts on our system, and I will talk to you a little bit about the positioning of those blowouts. You know, on an air relief valve, and you may need a flow meter and pressure regulation. My next slide gives me a little POs. This one here is a district purchase of point of connection. These are the devices that you would require and the order that they would be required on the system. First, if you're on a pervaded water system, they usually want a meter. That would be the first item on your system coming up after it's coming out of the ground. From there, I'm sorry about this button keeps, we usually will have to evacuate a blowout from a valve of some kind. In this case, you're just going to see a hose bib that's located right after a gate valve, an isolation valve. Why we do that is you cannot blow continuously through a backflow preventer. You'll blow the seats and poppets out of it and have to be replacing it far too often. You're better off to have a blowout connection where you can give it a quick blow through here, exhaust it through your main blowout chamber, which would be here after your backflow preventer, and go from there. You require a filter, would go in there. Pressure regulation. I feel there's some questions about this, but I feel if you need a pressure regulator because you have pipe pressure, put it as close as you can to the beginning of your system. You might as well protect all of these expensive devices that are in the system. So the closer you can have it to the beginning of your system, the better off you are. Pressure gauge is a necessity on a system, especially if you're in a circumstance where you have a filter. That is going to tell you how often to clean it. If you were to look at your system and find that with a filter, when the water is clean going through it, that the pressure gauge will show the maximum pressure you have. Some people will actually put a pressure gauge before and after a filter. So you can see there's a difference. When it's clean, the pressure should be just about the same going through here. When you have a difference of 5 to 10 pounds of pressure between the two gauges, it's telling you without opening it right to see how dirty it is that it's dirty and it's time to clean it. If you're going to fertigate, into a system. Usually, this, again, I feel that depending on the type of fertilizer, if it's a liquid soluble one, we're not going to worry about it. But if you're using some powders or something like that, you may want to have your fertigation device in before your filter. Fertigation devices can be as simple as a pressure differential. You can utilize a Venturi nozzle here to fertigate, or you could use a pump. Water delivery, let's get water to the roots. There are all sorts of different products for different circumstances that we're working with. And here we have emission devices, everything from drip irrigation devices to sprinklers. These are highly uniform, efficient sprinklers that we're recommending in a lot of circumstances. You can use them for anything from wheel lines to solid set irrigation systems. Big guns are used, well, they're still being used a lot on a lot of our pasture crops, the likes of that. On pivot systems, you're using these type of sprays. This gives you some of the idea. When you're talking different types of systems, we're talking about water efficiencies. I just want to go over some of that. Trickle irrigation is the highest form of efficiency. Subsurface drip obviously is the best. Subsurface drip isn't for everyone, but subsurface drip minimizes your evapotranspiration rates, and but it's put below the ground, which you have to, the installation of a subsurface drip irrigation systems is a whole new gambit. You have to, you're not seeing the system operate. You can have problems with the rodents and that chewing on your tubing, but there are a lot of methods right now to maximize that. Sprays that you would use in potted and nurseries and the likes of that, they're very efficient, about 85%. Inline and drip tapes, you're going to see around 92% efficiencies. Inline drip, most inline drip that's going in nowadays is a pressure compensating type. There is non-pressure compensating, which may not need it quite as fine a filtration, but you're not going to be able to run it as far. And if you have any hills or long runs, you want to go with a pressure compensating type of drip tapes. Are used in a lot of vegetable crops and the likes of that. Sprinklers. Here are some different sprinklers. Now, it's key, there are a lot of different sprinklers out there. There are an old brass impact sprinkler head, still works well. Nozzling is very important on those. But here again on your sprinklers, you can see some of the differences. The micro sprinkler being 75% efficient versus a standard sprinkler like a wobbler, maybe 72. If you go under tree, obviously we're closer to the ground. We use a lot of under tree systems on a lot of orchard crops still. They're fairly efficient at 75%. Wheel lines, hand lines are, we classify as being around 72% efficient. And we do find in a lot of circumstances on a lot of wheel lines and on a lot of hand move systems in our travels, there was an awful lot of erraticacies in the sizes of the nozzles along a wheel line, as well as the wear of a nozzle. I think it's very key to, if you want to maximize efficiency, if you can't afford to spend the most expensive, buy the most expensive system, you have a wheel line system or something like that, upgrade it. Maybe change the sprinkler heads. You could go to some of the newer models of sprinklers that are far more efficient, or at least change the nozzles on your system and make sure that the nozzles are of similar size all the way along. And other circumstances on wheel lines, we saw circumstances where the under drains underneath were leaking on a lot of them, and that was wasting a lot of water. So under drains and levelers, you should make sure that they're as leak proof as possible. Pivots, well, we all, in any field crops, a pivot system is probably as good as you can get, especially with the drop spray type of sprinklers are using them on them right now. You have 80%. They're so sophisticated that you're able to change the nozzles and the speed between each of the towers. They're great, but they're expensive. Retrofitting of old pivots down in the States, they have a system called a Dragon Line right now, where actually they've taken off all of this sprinkler structure off of it and they replaced it with a drip irrigation type of a system going off of an old pivot system. It was found to be a very sophisticated method of, or ideal method of operating when we didn't have a lot of pressure, and on different crops, it's worked out very well down in Texas. Reels, they're probably the most one of the most inefficient of systems, but also the most functional systems that you can use. I know that those of you that do have traveling guns, one of the biggest issues with them is maybe shutting them down. You can actually get phone apps right now onto software where you can actually, with the interface on there, you can actually control your traveler. You can monitor it shut down, and also adjust the speed. I think they have 3 or 4 different ranges. A traveling boom is something that can be retrofitted onto a traveling gun system. So on the end of your reel, instead of having a gun, you would have a boom spray, which this could be, I'm sorry for doing this so many times to you. It can be up to 60, depending. You can get them up to just about under 100 feet wide, and you have like a mini pivot system that you can utilize from that. Scheduling of the irrigation system. I think we will be having another session on scheduling. Scheduling is the best way that we are able to determine how long we should be watering for, and differences in what's happening actually out in the ground. Soils moisture sensors such as tensiometers and watermark sensors down in the ground are going to give you your moisture level in your soil. You want to have, depending on various crops, you don't want to have them in each crop. If you know of differences in soils, you may want to have that. Depending on what you're growing, obviously they're going to be installed at different heights, and you know, there are charts from these manufacturers which will tell you suggested depths of putting your sensors in. Andrew and I installed quite a few of these in our travels through the Kootenays last year, and on different crops. The tensiometer, the one thing I will say is they have to be pulled out of the ground each year, so it's a little bit more labor. Whereas the aerometer, the watermarks, they can stay in the ground, and you go around and you clip this meter on to get your readings. Not everybody can afford a weather station, but I just wanted to point out Farm West. Farm West has a weather station right now in multiple areas. They've expanded it many times now, and it's available. There are a few stations out in the Kootenays. Grand Forks is had one installed. The other things that I want to talk to you about are controllers and the opportunities that are out there. If you don't have power, battery operated controllers have come a long way. Wired systems right now, the key to a lot of wired systems now is you don't have to run multiple wires to all your different zones. You can run a 2-wire system where you have 2 wires feeding through your whole system, and you would connect in at each of your zone electric valves something called a decoder. The decoder hooks up to your controller, and so each decoder has a different, shall we say, frequency, so that when it is triggered to turn on, that specific decoder will turn on, but it's all off a 2-wire path. So expansion on it is unlimited to the amount of zones. A lot of the decoder controllers start at 100 zones. That's all I have for you folks today. I'm sorry that it took a little bit longer, but I hope that this information is going to be something that you find useful, and can hopefully bring you back to see some of our other sessions where we'll be coming into more detail on various aspects of efficiency in irrigation. Thank you.
Thank you so much, Bruce. We've got a couple of questions right off the bat. If you've got any others, please start sending them in by chat or throw up your hand. We've got a few minutes left for questions. You're such a wealth of information, Bruce. One of the privileges of the last year has been able to tap into Bruce's endless depth of irrigation knowledge. One question here, would you ever use ABS instead of polyethylene or PVC, and how is ABS different?
ABS isn't pressure rated. ABS is a plumbing pipe. There are, if it is an ABS with a pressure rating, which I know there is ABS in some valves and that, but any piping for ABS is not used for pressure situations.
And another one from David White, he wanted to know about Robert's spot spitters. He was considering a system using the spitters at 20 psi on apples and cherries, and he was wondering if there was how that compares with water savings to a typical drip, such as an inline drip, I imagine.
Well, a spitter is more in the microjet category than it is in the drip category. Robert spitters, there's been a lot of spitters installed in the Creston area, and with some with quite a bit of success out of them. A spitter is different than an emitter or a microjet, for example, has an orifice in it, and it can plug up if your filtration isn't fine enough. Whereas a spitter is a groove on the side of it, so it's a lot more difficult to plug that. And so that was the beauty of that spitter. Spitter, the key to a spitter system is to have don't go to too small a spitter, obviously, because it's going to plug up. The length of tube you have feeding off of it can be a problem, but as far as just spraying goes, as long as you keep your calculations, that should all be worked out so that your pipe sizing is correct. It'll work for very successfully in an orchard application.
Thanks, Bruce. To answer some of these other questions coming in, yeah, we will definitely be able to get a list of BC fact sheets. Also, we are planning another session specifically on scheduling and monitoring, where we'll go into more detail on soil moisture metering. We also did a project, Bruce and I, last year, where we'll have some data coming in from farms where we installed soil moisture meters, and we will be looking at some of that data coming in and how it's been helpful to farms. Another question, what about the efficiency of sprays? Why is it that sprays are considered more efficient than a sprinkler? Wouldn't they have high evaporation?
Which specific sprays are we discussing here? Sprays on a pivot system?
I think that's probably the best way to answer. Jets and all kinds of sprays. Pull the sprays apart for us, Bruce. Jets and sprays, micro irrigation.
Micro irrigation, we're operating micro irrigation at low pressures. Lower pressures mean larger droplets of water, which can minimize the evapotranspiration. If you utilize them close to the ground, it's going to minimize it. The higher a sprinkler head goes up. Now, for example, some people were using micro jets inverted upside down in a lot of trellised apple type of irrigation systems. But there's where you would have, with wind and the likes of that, you would have more evapotranspiration in circumstances like that. But close to the ground at low pressures, located properly, if a spray, if they say in the specifications that a microjet will throw a 15-foot diameter, and somebody spaces them that's 7.5 feet apart, you could not, your success may be limited. If you put your microjets close enough together, depending on the circumstance, closer to your tree, as long you're going to have a better success with it. Well, I was just going to say that the microjet, the benefit of it over a drip system is in the circumstance where you want to maintain a cover crop. It's going to allow you a little bit more spray to maintain that you would not get with a drip irrigation system.
Another question about application rates. We will be going into those in more detail in the next session, two sessions from now, when we'll look at the design of emission systems. But maybe, Bruce, you could sort of go over the differences in what is an application rate and what are the differences between, say, the application rate of a gun versus a wheel move.
Well, the first thing is, why are application rates important? Probably I think that's the first thing that you'd have to look at. Application, your soil, depending on what your soil is, it can only accept water at a certain rate. If it's cultivated or if it has a grass crop over the top of it. Well, like if you take, let's take an example. If you have a clay soil, you cannot apply water as quickly to it because it's going to puddle. If you have a sandier soil, the water is going to run through it, so you can apply water at a higher rate. Application rates typically are registered in inches per hour. So that's the amount of volume you're putting down on an area in a given period of time. If you exceed the application rate of your soil, then what you'll find is that it's just going to puddle and it's going to be very inefficient in your irrigation practices. Putting it into practice of a wheel move versus a pivot or something like that. A pivot with sprays on a drop, probably operating at a lower pressure, and so it has a better chance of being applied more efficiently. With a sprinkler on a wheel move or something like that, your application rates may be higher and you would have puddling.
We've got time for one last question, which I'll ask in a second here. First, to respond to Salmo Jack there on the walnut tree daily minimum. That's something that we'll look in more detail coming up, how to look at how much volume the roots are occupying, how much water the soil can store, and how much evapotranspiration you can expect at different times of the year. In the meantime, you might want to head over and have some fun plugging in numbers in the BC Agriculture Water Calculator as a start to get some estimates there. Last question of the night. It's already 7:30. Thank you so much, everybody, for coming. We have a question here on testing water quality. How would you go about testing water quality specifically to determine filtration sizing? In this case, from whether it's a groundwater source or a pond or a stream, how would you decide your filtration sizing?
Your filtration sizing is going to be determined more so for our application based on the emission devices that you're utilizing. We don't want to create bridging, so your orifice size that you have in drip irrigation systems and that is going to determine, we need something fine enough that it's going to take the particles out that would otherwise be plugging our emitters. That's what determines that. So if you were getting a water sample done on a groundwater source or something like that, you could take it, you could do a simple settling application. Andrew, you'd be better at that than I, because you do that all the time with your water sampling. So you could do that and see your settling of your sands and that so to the various particles in your water. If you were wanting an overall view of it, you may want to take a water sample and take it into one of the analysis labs that are around, especially if the quality of that water for the consumption, and that is important. But otherwise, we want to look at the amount of sediment that is in the water and what's potentially going to cause a problem. There are iron and other things that are going to precipitate in your water. That's something else you need to know. Because you have to treat for that as well.
Thank you so much, Bruce. And thank you everyone to coming out. I'd like to take one last opportunity to thank the funders, the people who have really made this possible, Climate and Agricultural Initiative of BC, and the Columbia Basin Trust, and a whole host of funding partnerships that they're involved with, also the Kootenay and Boundary Farm Advisors. Big thanks, Bruce, for coming out and sharing your wisdom with us tonight. And we look forward to seeing everybody in a couple of weeks when we dive into design. So have a good night.
Good night. Thank you.